So today what we're going to be doing is finding the mechanical advantage of two different sized bikes by measuring the radiuses of the wheel and axle.
Well, I'm not sure what this is gonna be, but with my eyes closed, all I see is the skyline through the window, the moon above you and the streets below. Hold my breath as you're moving in, taste your lips and feel.
The mechanical advantage is the number of times the machine increases the force exerted on it. The formula for mechanical advantage is the radius of the wheel divided by the radius of the axle.
For the small bike, the radius of the wheel was 8 inches, and the radius of the axle was 0.5 inches, and the mechanical advantage was 16 inches.
And for the big bike, the radius of the wheel was 10 inches, the radius of the axle was 0.5 inches, and then the mechanical advantage was 20 inches. So for this, the scientific concept is the wheel and axle.
The manipulated variable is the wheel size and the axle, and the responding variable is the mechanical advantage.
And the materials required, we did the small bike, big bike, the measuring tape, whiteboard, and markers.
First, we measured the wheel and axle of the small bike. The second step was we measured the wheel and axle of the big bike, and then we put all of our information into a table. Then we found the mechanical advantage of both bikes.
Well, because the wheel is larger than the shaft or axle, the axle rotates and exerts a larger output force. So the wheel and axle increases your force, but you also must exert your force over long distance. The results for our experiment was the small bike's mechanical advantage was 16 inches, and the bigger bike mechanical advantage was 20 inches. Okay. So this experiment could be turned into a music exhibit by, there could be different sizes of bike tires and bars allowing people to pedal on it to see the mechanical advantage results of the bigger and smaller axles and